Next, we will talk about the reactions of ethers. As I mentioned earlier, ethers are lack of reactivities. That's why they are used as solvents. So there are not many reactions of ethers. I will only introduce two here, and I will only test one, the second one. So the first reaction we want to talk about is very important regarding how we should store ethers. This is the oxidation of ethers to form hydroperoxide. So when a bottle of ether has been opened for a while, it's going to react with the oxygen gas in the air, and the oxygen gas, O2, can be inserted between the alpha carbon and the alpha hydrogen to form hydrogen peroxide. And this is a very dangerous material that it may cause explosion. So if you have an old bottle of ether, chances are there is hydrogen peroxide inside it. And the ethers will be stored under inert gases if possible. All right. The next reaction, the one that you need to know, is the acid-catalyzed cleavage of ethers. Ethers can be cleaved by hydrogen halides. So for example, if we have excess HBr, we basically need two equivalent of HBr here. And we will get two alkyl halides and water. The carbon-oxygen bonds will be cleaved to make alkyl halides. So let's use the reaction between diethyl ether and HI, hydrogen iodide, as an example to illustrate it. The first step under acidic condition, protonation. So the ether oxygen will be protonated. Then iodide serves as the nucleophile to attack the carbon next to the oxygen. This will make one alkyl iodide and an alcohol, right? So it makes one alkyl halide and an alcohol. Then the alcohol will further react with the hydrogen halide to make the second alkyl halide. And that's the reaction you have learned before. So protonation on the alcohol, then nucleophilic substitution. So in this mechanism, we have two SN2 reactions. The halide will replace the oxygen on the alkyl group. It's pretty straightforward, okay? So the ethers will be cleaved under acidic condition like this. But I want you to take a look at this next reaction. We have an aromatic ether. So on one side it's a benzene ring, on the other side of the oxygen it's an ethyl. We still have excess HBr. What product will you get? Will you get two alkyl halides or no? So you need to keep in mind that the reactions to make alkyl halides are SN2 reactions. Will we be able to carry out two SN2 here? If not, what will be the products? So we will verify the answer in class.